Welcome to this video. Today we're going to talk about proving lines parallel, and our specific objective is to determine whether two lines are parallel. We're going to start with the converse of the alternate interior angles theorem. And let's back up for a second. First of all, we learned about the alternate interior angles theorem from the last chapter. We're going to do the converse, and remember, converse means to just switch the hypothesis and the conclusion. Well, in our previous video, everything started out with if parallel lines. Now, everything is going to conclude with then parallel lines. So again, we've just switched. Let's get started. The converse of the alternate interior angles theorem says, if two lines cut by a transversal form alternate interior angles that are congruent, then we conclude that we have parallel lines. So looking at this diagram here, if we're given that angle 3 is congruent to angle 5, well then we could conclude that line L is parallel to line M. And if we are given that angle 4 is congruent to angle 6, well then we can make the conclusion that L and M are parallel. And the converse of the alternate exterior angles theorem is similar. It says if two lines cut by a transversal form alternate exterior angles that are congruent, then we can conclude that we have parallel lines. So in this diagram here, if we're given that angle 1 is congruent to angle 7, and just to review, alternate exterior means that we have angles that are on opposite sides of the transversal, and they are on the exterior portion between these lines here. So if angle 1 is congruent to angle 7, well, we can conclude that we have two parallel lines. And if we're given that angle 2 is congruent to angle 8, well then we can make the same conclusion, that L is parallel to M. Now we have the converse of the same side interior angles postulate, and it says if angle 4 and angle 5, if we take their measures and they have a sum that equals 180, we can conclude that we have parallel lines. So specifically, if the measure of angle 4 plus the measure of angle 5 equals 180, then L is parallel to M. Well, for 3 and 6, let's actually plug in some numbers. Let's replace 3 and 6 with 120 and 60. Well, taking a look at 120 and 60, if we add these up, they have a sum of 180. Since they have a sum of 180, we can conclude that L is parallel to M. Now the converse of the corresponding angles theorem, again, very similar. If two lines form corresponding angles that are congruent, then we can conclude that we have parallel lines. So in this diagram here, angle 1 and angle 5 are corresponding angles, and if we're given that they're congruent, we can conclude that these two lines here are parallel. If we're given that angle 2 and angle 6, again, those are corresponding angles, and if we're given that those are congruent, we can conclude that we have parallel lines. We only need one pair of corresponding angles that are congruent to prove that these lines are parallel. We do not need all four pairs. We just need one of them. Aha! Here I am with Aida. She went with me on my parallel line hunt, and we found that there are parallel lines in these bricks here, and if we take a look at this window, well, the window has parallel lines, and then it also has parallel lines going this way as well. So Aida took a break from her dress coding to help me find some parallel lines. Now we're going to do the converse of the alternate interior angles theorem. We're proving what we just talked about in the previous slide. When we're looking at this, we have to pretend like we don't know yet that if alternate interior angles are congruent, that proves lines are parallel. We're taking the time to prove where we got that theorem. We're given that angle 4 is congruent to angle 6. I clearly see that we have vertical angles, and we know that vertical angles are congruent. So what we're going to do to build our proof is we're going to take what we have given, Angle 4 is congruent to angle 6. And we're also going to take the fact that vertical angles are congruent to build this proof. So let's start with our given, and then we're going to add what we just talked about. Angle 2 is congruent to angle 4. Well, that's just the vertical angles theorem. And now take a look here. We have two angles that are both congruent to angle 4. Therefore, they are congruent to each other. Well, that's the transitive property of congruency. Taking a look at our diagram, we are left with angle 2 is congruent to angle 6. But if corresponding angles are congruent, then we have parallel lines. We're taking something that we've learned previously to prove that L is parallel to M. If corresponding angles are congruent, then parallel lines. So we just proved the alternate interior angles theorem. Alright, one thing left to do. We're going to use some algebra to solve for x to find a value that would make L parallel to M. So if we set up an equation and make the same side interior angles equal to 180 and solve for x, well, that value then would make L parallel to M. Remember, same side interior angles have to be supplementary for these lines to be parallel. So our equation would be 2x plus 9 plus 111 equals 180. And then just simplifying, 2x plus 120 equals 180. And then I'm going to use the subtraction property of equality to subtract from both sides. I'm left with 2x equals 60, and then do the division, POE, and that leaves me with x equals 30. As usual, it's been a lot of fun. I'll see you guys in class.